The first coders, exploring the origins of coding languages. Presentation overview, evolution of programming languages. From early machine languages to high-level languages, programming languages have evolved over time to make programming easier and more efficient. Pioneers of programming languages. Ada Lovelace, Grace Hopper, and John Backus were pioneers of programming languages who made significant contributions to the field of computing. Key contributions to computing. Programming languages have made many key contributions to computing, including the development of operating systems, the internet, and databases. Evolution of programming languages. First generation, machine languages. Machine languages are the earliest programming languages to be used and were specific to the machine they were running on. They were difficult to use and required extensive knowledge of the hardware architecture. Second generation, assembly languages. Assembly languages were developed to make programming easier than machine languages. They used mnemonics to represent instructions and allowed for more complex programs to be written. Third generation, high-level languages. High-level languages are the modern programming languages used today. They are much easier to use than assembly languages and machine languages as they are closer to natural human language. Some popular high-level programming languages include Java, Python, and C++. Machine languages. Machine languages were the first programming languages to use binary code to program computers, where each command was represented by a series of zeros and ones, making it a tedious and error-prone process. Assembly languages, human-readable instructions. Assembly languages were the second generation of programming languages that used human-readable instructions to program computers. Low-level code. Although easier to read than machine languages, assembly languages still required programmers to write low-level code. High-level languages. High-level languages are the third generation of programming languages that abstract away low-level details, making programming easier and more intuitive for humans. Pioneers of programming language. Ada Lovelace. Ada Lovelace was a mathematician and writer who is considered the world's first computer programmer. She worked with Charles Babbage on the analytical engine and wrote the first algorithm intended to be processed by a machine. Grace Hopper. Grace Hopper was a computer scientist and United States Navy Rear Admiral. She was one of the first programmers of the Harvard Mark I computer and developed the first compiler for a computer programming language. John Backus. John Backus was a computer scientist who developed the Fortran formula translation programming language, the first widely used high-level programming language for scientific and engineering calculations. Ada Lovelace, first algorithm. Ada Lovelace is credited with writing the first algorithm, laying the foundation for modern computing. Analytical engine. Ada Lovelace saw the potential of Charles Babbage's analytical engine, and her work laid the foundation for modern computing. Grace Hopper, compiler development. Grace Hopper developed the first compiler, a program that translates high-level code into machine language, revolutionizing the field of computer science. COBOL programming language. Grace Hopper created the COBOL programming language, which is still used today in finance and other industries for business applications. John Backus, Fortran. John Backus created the first high-level programming language, Fortran, which made it easier for programmers to write complex computer programs. Backus-Naur form. Backus-Naur form is a notation developed by John Backus that is used to represent programming languages. It made it easier for programmers to understand and write programming languages. Contributions to computing. Compilation. Compilers are programs that translate high-level programming languages into machine language, making it easier to write and understand code. They have been instrumental in building modern computer systems and applications. Object-oriented programming. Object-oriented programming is a programming paradigm that enables the creation of complex software systems by modeling them as a collection of objects that interact with each other. It has been instrumental in building modern software systems, including web applications and video games. Artificial intelligence. Programming languages have played a key role in the development of artificial intelligence, enabling the creation of intelligent machines that can learn from data, reason, and interact with humans. This has led to breakthroughs in fields ranging from image recognition to natural language processing. Compilation. Compilation is the process of translating high-level code into machine language. It was made possible by the development of the first compiler by Grace Hopper. Object-oriented programming. Programming paradigm. Object-oriented programming is a programming paradigm that organizes code around objects rather than functions or procedures, making it easier to understand and maintain. Object-oriented languages. Object-oriented programming was made possible by the development of programming languages like Smalltalk and C++, which allowed for the creation and manipulation of objects. Artificial intelligence. Artificial intelligence is the development of computer systems that can perform tasks that typically require human intelligence, such as learning, reasoning, and problem solving. It has contributed greatly to the development of autonomous systems and robotics. Conclusion. Revolution of computing. The development of programming languages has revolutionized computing and enabled us to build the advanced systems we use today. The ability to write code has transformed the way we work and live. Pioneers of programming languages. We owe a debt of gratitude to the pioneers who had the vision and courage to create the first programming languages. This sets the foundation for modern computing. Thank you.